Machine learning. You've heard the term, right? It's everywhere. It's powering everything from your movie recommendations all the way to some seriously cutting-edge science. But what is it really? Well, today we're going to pull back the curtain and really get to the heart of this powerful technology. And this question, it's really the heart of the whole thing. It was first asked way back in 1959 by an IBM researcher, Arthur Samuel. See, he built a program that learned how to play checkers. And here's the kicker. His program eventually got so good, it could play better than he could. That one idea, that a machine can improve all on its own, just through experience, that's the key. And what started as this kind of niche academic question, well, it just exploded. This chart shows it perfectly. For decades, the term machine learning was just hiding out in research papers. And then, right around the 1980s, it just takes off like a rocket. We are living on the vertical part of that curve right now. So how are we going to tackle this huge topic? Here's our game plan. We'll start with the basics, what machine learning even is. Then, we'll look at the two main ways machines learn from examples. After that, we'll take a peek inside the digital brain that makes it all work, get our heads around the game-changing transformers, and finally, we'll talk about what this all means for the future. Okay, so let's get right down to it. Machine learning is the science of getting computers to act without being explicitly programmed for every single little thing. So instead of a programmer writing endless if-then rules, we just give the machine a bunch of data and let it figure out the rules for itself. Now, the most common way machines learn is, well, with a teacher. It's something called supervised learning. Think of it this way. It's like you're a teacher giving a student a huge stack of flashcards with questions on the front and the correct answers on the back. That's exactly what's happening here. So, with supervised learning, we're basically giving the algorithm an answer key. We're training it on data where we already know the right answers. And it has two main jobs. The first is predicting a number, like the future price of a stock. And the second is sorting things into groups, like deciding if an email is spam or not. And what's cool about this slide is how it shows you those two jobs. Over on the left, you've got what's called regression. That's where you're trying to fit a line to the data to predict a future value. And on the right, you've got classification, drawing a line to separate different groups. So you're either predicting a number or you're choosing a category. Simple as that. But what happens if you don't have an answer key? What if all you have is a big jumble of data? Well, that's where unsupervised learning comes into play. In this case, we just dump the data on the machine and say, hey, you figure it out. Find the interesting patterns in here for me. So one of the main things you do here is called clustering. The algorithm just looks at all the data points and starts grouping together the ones that are similar. As you can see here, it's basically measuring how close different points are to each other, kind of like finding natural cliques in a big crowd. This is super useful for things like, say, finding different types of customers for marketing. Okay, now here's a little secret from the inside. A huge, and I mean huge part of machine learning has nothing to do with fancy algorithms. It's the not-so-glamorous work of cleaning up the data. Because raw data, it's messy. So take a look at this. Seems simple, right? We've got a tiger, a lion, a tortoise. The data's not wrong, but if our goal is to figure out if an animal eats meat, having tiger and lion as separate things might just be adding extra noise that confuses the model. And now, boom, look what happens. By simplifying things, we've just merged tiger and lion into one much more useful category, carnivore. This helps the model see the big picture, the real difference between meat eaters and non-meat eaters, instead of getting bogged down in the details. This kind of prep work is absolutely crucial. Okay, so we've got our data, and we've got ways for the machine to learn from it. The next giant leap was to build learning systems inspired by the most incredible learning machine we know of, the human brain. And this leads us to neural networks. And this little thing right here is the fundamental building block. It's called a perceptron. You can think of it as the simplest possible artificial neuron. It's like a tiny Lego brick. It takes in some information, thinks about it for a second, and spits out a single answer. It's a tiny, tiny decision maker. So how does this little guy actually learn? Well, it's this really elegant, simple loop. It takes in some data, it makes a guess, and then it checks to see how wrong it was. Based on that error, it tweaks its internal settings just a tiny bit to make a better guess next time. And it just does this over and over and over again, thousands of times, getting a little bit smarter with every single cycle. And you know that big buzzword, deep learning? It's not nearly as complicated as it sounds. It literally just means we're taking these artificial neurons, these little perceptrons, and stacking them together in multiple layers. Each layer learns to spot different kinds of patterns, allowing the whole network to solve much, much more complex problems. Now, for a long time, even these deep neural networks had some big problems, especially when it came to understanding the flow and context of human language. And then, in 2017, this new design, this new architecture called the transformer came along and just changed the entire game. This diagram shows the core idea brilliantly. A transformer basically has two parts. On the left, you have an encoder. Its job is to read an entire sentence and just get it, to build a really rich understanding of what it means. Then the decoder, on the right, takes that deep understanding and uses it to generate a brand new sentence, one word at a time. This is the magic behind all the modern chatbots and translation tools. And the amount of data we're talking about here is just mind-blowing. Take BERT, one of the first really famous transformers. It learned the subtleties of human language by reading over 3 billion words from Wikipedia and Google Books. That's the scale of experience these things are built on. So when you put all of this together, from simple predictions to deep neural networks to these incredibly powerful transformers, you get something truly extraordinary. The whole field has shifted. We've gone way beyond just spotting patterns and into a world where machines can actually create and generate completely new things. I mean, this technology is already woven into the fabric of our lives. It's writing articles and emails, it's spotting objects for self-driving cars, it's translating languages on the fly, it's powering the recommendation engines that tell you what to watch next, and it's even spotting fraud in millions of financial transactions. So look, if there's one single thing you walk away with today, let it be this. Machine learning isn't about giving a computer a perfect list of instructions. It's about building systems that can learn and get better all on their own, automatically, just by experiencing more data. And that leads us to this one final, fascinating question. Using all these ideas, we've taught machines how to see our world, how to speak our language, and even how to create art. The foundation is there. So the real question for all of us is, what on earth should we teach them to do next?